So this is our first question from circular motion. Says a mass moves on a circular path of radius 2 meters. So what is given here is the radius of 2 meter, and it is moving in a circular path with a constant speed of 4 meter per second, right? So first thing we want to note here is that the speed is constant, which means it is a case of uniform circular motion. Okay, so if we have studied the chapter, we know that in uniform circular motion, the acceleration of the object is always pointing towards the center. Okay, so that is the key to understand circular motion, right? So object, though it is moving with a uniform speed, right? Basically, the acceleration points towards the center, and that is called centripetal acceleration. Okay, so now we move on and read the question. So first thing first, if we want r is 2 meters, and the speed at which it is moving is 4 meter per second. Okay, so the question says calculate the magnitude and direction of average acceleration during a quarter of revolution. Okay, so suppose the object starts from here and moves all the way to B. What is the average acceleration, right? So we need to calculate the average acceleration. So as the term average appears here, it means that the average, whenever we are going to find, we have to find the initial acceleration at point A, and then find the acceleration at point B, add it up, and then divide by 2, right? So this is how we find the average. But as we do the acceleration is a vector quantity, we have to add this acceleration using vectors, okay, along with the direction. So that would be our approach for finding the average acceleration. In the part B, it says also find the centripetal acceleration of the mass, right? As we know, it is going to be always pointing towards the center, hence it is called centripetal, right? And the value of that we know is always v square by r. So let's start by finding part B first, because that's easy. So we know the centripetal acceleration is going to be magnitude v square by r. V is given to be 4, so that's going to be 4 into 4 divided by r, which is 2. So this and this will cancel, and we will get 8 meter per second square, right? So at all the point when the object is doing a circular motion, it is experiencing an acceleration 8 meter per second square, which is towards the center. So now, so that answers part B very easily, right? If you just know the formula and understand the concept of centripetal acceleration, you will be able to find that pretty easily. Now, in order to find the average acceleration, as we have said, we have to find the initial acceleration, right? So if the object is moving in a circle, right, starting from here, its acceleration is going to point upwards towards the center, right? So my initial acceleration is going to be like this, and it has a magnitude 8 meter per second square. When it reaches point B, or when it covers the quarter of the circle, its acceleration is now going to be facing towards the left, right? Facing towards the left, and now it is again same magnitude, but change in direction. Okay, as you can see, now this is perpendicular, right? So it will be easier if we can represented by a vector, so that we can add them properly, right? So we are going to use the Cartesian coordinate system. This is x axis and this is y axis. So my initial acceleration, which is this one, upward. So this is my acceleration at A is upward, and it is pointing upward. So we can say the acceleration at A is 8, which is the magnitude, and the direction is positive y, right? So we are going to say j cap. Okay. Now when it reaches point B, so this is our acceleration vector at point B, and this is pointing towards the left, which means now we can say the acceleration at B is again 8, but this time with minus I, because it is towards the left, right? So we can say minus I. Okay. So in order to find the average, we have to add them up. So let's add them up. Acceleration of A and acceleration at B, right? So this is going to be minus 8I plus 8j, right? It is convention to write the I first. So we have found the sum of this in a vector format. Now, to find the A average, okay, we have to divide it by 2, right? So that's how we find the average. So let's find that. So we are going to divide it by 2, and that's going to be minus 4I plus 4j, right? So when we are dividing in a vector, we just divide the x component, y component separately, right? So this is simply dividing by the integer. So it's minus 4I plus 4j. So that is going to be our average acceleration. But the question says we have to find the magnitude and direction. Okay. So let's find the magnitude first, right? To find the magnitude of a vector, which is something like x component I plus y component j. How do we find the magnitude of a vector? is simply the x component square plus the y component square. So here my average acceleration is going to be under root minus 4 square plus 4 square. This is going to be 2 times, sorry, this is going to be 2 times into 4, right? 4 into 4, 4 square, right? So 2 times 4 square. 4 square will come out of the square root and we'll get 4 root 2, right? That's the magnitude, and the unit will be meter per second square, right? Now, what will be the direction of this by adding these two vectors, which you can see here, A and B? The direction we can find out because they are of the same magnitude. It's going to be perpendicular like this, right? Intersecting at a 45-degree angle, and this is going to be our direction, right? So we can write what is the direction. This is north and this is west, right? So in between northwest, so my direction is going to be northwest in this case, and that is how we solve this circular motion problem. This is a very good problem because it helps you understand how the acceleration keeps on changing despite when the object is moving with a constant speed in a circular motion, and how we can find the averages as well as the magnitude of the centripetal acceleration.